Hey everyone, and welcome to section 10.4. This is going to do it for us for Math 120 for this summer session. And yeah, let's finish this material. So we're just going to end kind of taking a very brief look over the properties of logarithms. If you recall, perhaps what seems like a lifetime ago, we have these different properties of exponents. We used them kind of extensively when it came to simplifying polynomials and rational expressions and radical expressions, right? We use them a lot. Well, we have the same kinds of properties for logarithms. So let m and n be positive, a be positive and not equal to 1, and let p be any real number. The first thing we should know, and it's not really a property, I guess, but the base a logarithm of 1 is always equal to 0, regardless of what a is. The base a logarithm of a is always 1. If you take a, raise it to the log of a power, you just get x back. And similarly, if you take the logarithm of an exponential, you just get x back. So these are what are called the inverse properties. Remember I mentioned before that the exponential and logarithm are inverse functions to one another. All right, next we have this product property. If you have m times n inside of a logarithm, you may separate them and add the powers together. And actually, this property comes as a result of the similar one for exponents. You know, this a to the m times a to the n equals a to the m plus n. So all of these properties of logarithms can be derived using analogous properties of exponentials and rewriting. Anyway, we also have a quotient property. In this case, you're going to be subtracting. Makes sense because with exponentials, when we divide, we subtract exponents. And here we have a power property. Remember that for exponentials, when we raise powers to powers, we multiply exponents. Well, that's kind of what we are doing here in this last property. So now what we're going to do is use those. Right, so what we're going to be doing here is using these properties to simplify some expressions. There's basically two things you can do. You can condense multiple logarithms into one, and you can expand one logarithm into the sum or difference of logarithms. All right. So actually, looking at this first one, we have 2 times log base 2 of x. And we can apply this power property to that situation to rewrite it as log base 2 of x squared. But that's not all, because we have 2 logarithms with the same base being added together. We can also look at this product property. And there we have a condensed logarithmic expression. All right, let's look at the second one. So these first 2 logarithms are being added together, which means we can combine them by multiplying. And then this creature here, the log base 5 of y is being subtracted. So then we're going to be applying this quotient property. And that's it. Lastly, I can apply my power property again for actually both of them. Then I can use my quotient property. And that's that. Okay, we're going to do now the opposite operation in some sense. We're going to get it as expanded as possible. using these properties. So first up, I have the natural logarithm of x to the 4th over y to the 9th. And I know I can apply my quotient property. So that would be ln of x to the 4th minus ln of y to the 9th. And then I can also use this power property because I want it to not have any exponents in the end. I end up with 4 ln x minus 9 ln y. Next up, I have the common logarithm of a to the 7th b squared. And let's see, so I can use my quotient property again. And I can use my product property to separate those in the first logarithm. Then I'm going to use the power property to pull all the exponents out. Okay, last example. And there we have it. All right, everyone. Well, that wraps it up for this section, which wraps everything up for the course. Just want to thank you all again for taking the class and working seriously through these coronavirus times. Your cooperation has been really appreciated. So thanks a lot, and I hope that you have a good upcoming school year. Bye.